Hello everyone, welcome back. In this video, we're going to look at some examples of sets. So, before we dive into any examples, let's look at some proof strategies. All right. So sometimes if you're given a statement which looks like statement one, which says A is a subset of B. So in most cases, in all cases, this just means visually this just means A is in B. That means all elements in A can also be found in B. So for example, if X is an element in A, since A is a subset of B, it also means X is also a element of B. Now if you're given a statement like statement 2, which says A equals to B, this means A is a subset of B and B is a subset of A. So if X is an element of A, then it also implies that X is an element of B. This double arrow means implication in both directions. X is an element in A means it also implies X is an element of B, and since A equals to B, X is an element of B also implies that X is an element of A. Now let's look at what these two statements mean. So if we have an element X, which is a element which is part of A union B, then this means X is part of A or X is part of B. So for example, consider these two sets, A, which is 1, 2, 3, and B, which is 3, 4, 5. So the union of both these sets, A union B, will be 1, 2, 3, 3, 4, 5. Right? So if we take X, which is an element, as 3, then this means 3 is, and since 3 is a member of A union B, then this means 3 is in A and 3 is in B. And if we take another element such as 1 as X, so 1 in A union B means either 1 is in A or 1 is in B. In our case, 1 is in A. So let's look at what X is part of A intersection B means. So X is part of A intersection B basically means X is both part of A and X is part of B instead of or. So like our previous example, A intersection B, the A intersection B is a set of just one element, 3, the common element. So X is part of A intersection B basically means that 3, which is part of A intersection B, is both in A and B. So let's look at some examples to make this less blurry and give you a clear idea of what's happening. So let's consider this example which says prove this statement. All right, so I'm going to denote the left hand side by P and the right hand side by Q. So we're told to prove P equals to Q. So remember from the previous part, to prove P equals to Q, this P equals to Q simply implies P is a subset of Q and Q is a subset of P. And also remember from the previous part, to prove something like this, to prove P is a subset of Q, all we need to do is show that an arbitrary element X, which is in P, is also in X is also in Q. So X is in P also means X is in Q. So let's go apart and prove this. Right, let's go for a different color for the proof. Right, so proof. So there are two directions to prove in this. So let's prove the first direction. So to prove the first direction, we can assume, remember from the previous video, we can assume remember this, whenever we're doing proofs, it's always good to write down what we can assume and what we need to show. This will help us move in the right direction. So we can assume x, which is our arbitrary element, is in A union B intersection C. So what does this mean? Remember, this is a union, so this implies implies is denoted by the single arrow, one directional arrow. So this implies x is in A or x is in B intersection C. So and x is in B intersection B intersection C. This further implies that x is in B, and remember from the previous part, whenever it's intersection it means and. So this implies x is in B and x is in C. So let's see what we have to show. So we have to show that x, this arbitrary element we chose, is also in A union B intersection A union C. So to show this, we need to show that what we need to show is we need to show that x is part of A union B, and remember this is an intersection, so we need to show it x is part of A union B and also x is part of A union C. So to show x is part of A union B, we just need to show x is part of A, or because it's a union, we just need to show x is part of A or x is part of B. And to show x is part of A union C, we need to show x either x is in A or x is in C. So remember that we're assuming this. So we're assuming that either x is in A or x is in B intersection C, or it can be in both. But first, since there are two cases that either x is in A or x is in B intersection C, first let's assume the first case, that x is in A. Now, I hope you can see this. This is pretty trivial. If x is in A, we need to show that either x is in A, or we need to show either x is in A or B, and we need to show x is in A or x is in C. Since we assumed x is in A, so this just means x is this part is proven and this part is proven. So x is in A basically implies that x is also in Q. Right. Now this is pretty trivial. If you're not getting this, please try to pause the video and go through it again. Let's prove this. Let's assume now the second part, which is x is in B intersection C, which we said means x is in B and x is in B and x is in C. So if x is in B, that means this case is proven since x is in B, and since x is in C, so say, remember we're assuming that x is in B and we're assuming that x is in C. Since x is in B, this first part is proven. Since x is in C, this second part is proven. So we've just shown that now x is in Q when we are assuming the second case, which is this. So I hope you're all getting this. Now let's do the second part of the proof. Right. In the second part of the proof, where we are doing the reverse direction. So this time we're assuming that x is a part of A union B intersection A union C. So let's dissect what this really means. Remember, so let's go step by step. This is an and, so this means X is part of A union B and X part of A union C. So let's see what this further means. This further means that X is part of A or X is part of B and X is part of A or X is part of C. What do we need to show? We need to show that X is part of A union B intersection C. So to show this, let's dissect it down. Remember that this is a union. So to show this, we need to show that X is part of A or X is part of B intersection C. So now we have all the tools. Let's see how it all fits in. So one more time, we can assume this. We're assuming X is part of A or X is part of B and X is part of A or X is part of C. And we need to show this, that we need to show that either X is in A or X is in B intersection C. So when X is in A, when A, it automatically proves this case. So this is pretty trivial and we're done. So when X is in A, so the first step what we did was we took X is in A and X is in A. So next let's do when X is in A and X is in C. So when X is in A and X is in C, we have already shown that, so we need to show that either X is in A or X is in B intersection C. So this is pretty trivial. I hope you can see that as long as we assume X is in A, we've already shown the first part. So now let's assume the third case. Remember, there are 4 scenarios for us to consider. Let's assume the third case where X is in A, X is in B and X is in A, and the fourth case is X is in B and X is in C. So in the third case, this is a B. When X is in B and X is in A, that X, since X is in A, this automatically implies the first part. So this is proven. The first case is true, the second case is true, the third case is true. Let's see what about the fourth case. So when X is in B and X is in C, that means that this case is true, but it doesn't mean that this case is true. But since this is OR, we just need to show one of them is true. So when we're assuming the fourth case, X being part of B intersection C is true, but X being part of A is false. But since this OR statement, since one of them is true, the whole statement is true, and thus we're done. So QED to the proof. We are done with the proof. So I hope you have gotten this example. Hope you enjoyed the video. See you next time.